For nearly 20 million years, one creature ruled every ocean on Earth. Not a dinosaur. Not a whale. A shark so massive that a single tooth was the size of your hand. Otodus megalodon. The megalodon stretched up to 24 meters long and weighed as much as 10 elephants. Its jaws could crush a small car. Its bite force exceeded that of a Tyrannosaurus rex. And then, 3.6 million years ago, it vanished. This isn't a story about a movie monster. This is the true scientific account of why the ocean's ultimate predator couldn't survive the changing world. And the answer is far more complex than you think. Before we understand its death, we have to understand its life. Megalodon appeared approximately 23 million years ago during the early Miocene epoch. For context, this was long after the dinosaurs went extinct, but millions of years before the first humans walked the Earth. Recent research from 2024 has fundamentally changed how we picture this animal. For decades, scientists modeled Megalodon as simply a supersized great white shark, thick, stocky, and round. But CT scan analysis of vertebral columns found in Belgium and Denmark revealed something different. Megalodon was more slender and elongated than previously believed. Why does this matter? A more streamlined body meant a longer digestive canal. This allowed Megalodon to extract more nutrients from each meal, meaning it didn't need to hunt as frequently as earlier studies suggested. But here's the critical detail. It still needed to eat enormous amounts. We're talking about consuming large whales, seals, dolphins, and even other sharks. Fossilized whale bones bear the unmistakable crescent-shaped bite marks of Megalodon teeth. The shark was also warm-blooded, a trait called regional endothermy. In 2023, researchers used clumped isotope thermometry on fossil teeth to prove Megalodon maintained elevated body temperatures compared to surrounding water. This gave it incredible advantages: faster swimming speeds, access to deeper waters, and the ability to hunt more efficiently. But warm-bloodedness came with a deadly cost. Megalodon's extinction wasn't caused by a single catastrophic event. Instead, it was a perfect storm of interconnected factors that slowly strangled the species over hundreds of thousands of years. Factor 1. Climate change and habitat loss. During the Pliocene epoch, Earth entered a period of significant global cooling. Between 7 and 3 million years ago, temperatures at mid-latitudes dropped by approximately 15 degrees Celsius. Glaciation intensified at the poles. Ocean circulation patterns fundamentally restructured. For Megalodon, this was catastrophic. As a warm water-adapted predator, it thrived in tropical and subtropical coastal environments. These shallow, productive waters served as nursery areas where Megalodon pups could grow safely while feeding on abundant prey. When sea levels began oscillating dramatically, these crucial coastal habitats shrank or disappeared entirely. The sharks lost not just hunting grounds, but the very nurseries where the next generation developed. Without safe spaces for juvenile sharks, population replacement rates plummeted. Factor 2. Prey collapse. Climate change didn't just destroy habitat, it devastated Megalodon's food chain. The shark primarily hunted large baleen whales, particularly species like the now extinct cedotherids. As ocean temperatures dropped, these whales faced two choices: adapt or migrate. Many whale populations moved toward colder polar waters, following the krill and plankton blooms that sustained them. But Megalodon, adapted for warmer waters, couldn't follow. Other whale species went extinct entirely during this period, taking about a third of all large marine animals with them. Here's where the warm-blooded metabolism became a liability. Maintaining an elevated body temperature requires enormous energy input. Researchers estimate Megalodon needed to consume vast quantities of meat just to survive. When prey became scarce, the energy equation stopped working. The shark burned more calories than it could acquire. While Megalodon struggled with a changing climate and disappearing prey, a new challenge emerged from an unexpected source: competition. Around 5 to 3.5 million years ago, ancestors of the modern great white shark began diversifying. For decades, scientists believed great whites descended from Megalodon. We now know they're not directly related. They're more like distant cousins who evolved similar features independently. But here's what matters: they competed for the same food. In 2024, researchers using cutting-edge zinc isotope analysis examined fossil teeth from both species. The results were striking. Megalodon and early great white sharks showed overlapping isotope signatures, indicating they hunted similar prey. This wasn't peaceful coexistence, this was direct dietary competition. Great whites possessed several advantages. They were smaller, requiring far less food. They could survive in cooler waters where Megalodon couldn't venture. They were more adaptable, more efficient, and better suited to the changing ocean. Early killer whales also emerged during this period, adding another apex predator competing for large marine mammals. Megalodon suddenly found itself in a world where it had competition for a shrinking food supply. You might wonder, how can scientists be so certain about events that happened millions of years ago? The answer lies in the teeth. Shark skeletons are made of cartilage, not bone, so they rarely fossilize. But teeth? Teeth are covered in enamel and preserved beautifully. Megalodon left behind thousands of fossil teeth on every continent except Antarctica, creating a remarkably complete record of its distribution and timeline. The last reliably dated Megalodon tooth is approximately 3.6 million years old. After that point, nothing. No teeth, no vertebrae, no trace. The absence of evidence becomes evidence of absence. But teeth tell us more than just when Megalodon existed. Modern techniques like oxygen isotope analysis reveal body temperature. Zinc isotope ratios indicate diet and trophic level. CT scanning of vertebrae reconstructs body shape and size. Bite marks on whale fossils document hunting behavior. Each tooth is a time capsule, preserving chemical signatures from ancient oceans. Together, they paint a picture of a species pushed beyond its limits. Megalodon's extinction holds crucial lessons for understanding modern ocean ecosystems. Today, over a third of all shark species face extinction, primarily from overfishing, a threat Megalodon never encountered. Researchers studying Megalodon's disappearance provide insights into what happens when apex predators vanish from marine environments. The loss of Megalodon likely triggered cascading effects throughout Pliocene food webs, altering predator-prey dynamics for millions of years. Modern great white sharks, despite surviving where Megalodon failed, now face similar pressures: climate change, prey depletion, and habitat loss. The difference? These changes are happening far faster than during the Pliocene, giving species less time to adapt. Megalodon's adaptations, its massive size, warm-blooded metabolism, and specialization in hunting large prey were assets for millions of years. But when the world changed, those same traits became liabilities. The shark was too specialized, too energy-dependent, and too inflexible to survive. So here's the truth about Megalodon's extinction. There was no single cause. No asteroid, no superpredator, no sudden catastrophe. Instead, a combination of climate change, habitat loss, prey depletion, and increased competition created a world where the ocean's largest predator simply couldn't exist anymore. For 20 million years, Megalodon was unstoppable. Then the rules changed. And that's the real story of extinction, not a dramatic ending, but a slow recognition that the world has moved on without you. This is the science behind deep time. This is how giants fall. Thanks for watching, and if you enjoyed this journey into our planet's past, make sure to like and subscribe for more.